Okay, thank you once again. Happy weekend. Hope we're good. So today we are going to move to an interesting subject. Before I introduce, just make sure I'm sharing my screen so we can all see what I'm doing. Apologies once again for starting a bit behind schedule. So for today, before introduce to this topic, I wanted to check with everyone regarding the project for last week. Um, I, for those that have a go, well, we've learned one or two, and I'm quite impressed by how seriously people are taking this. Still those that submitted, well done. So that's the only way to learn, because you will definitely come challenges and weekly. So I'm gonna, if you don't mind. Yeah, the system is throwing me off. I do apologize. Sure, sharing my screen again. Okay, I was kind of going back, trying to speak a little bit about the last task for week 4. So I like to always kind of mention a name that someone that I think jumps out in terms of the level of effort put into the work for last week. So if you permit me, I always like to mention a name or two. I think for last week, I probably would mention Ahmed, Ahmed. So I think he kind of went above and beyond regarding his work. For me, he kind of stood out. Obviously, going back his current knowledge base in terms of what he knows regarding DevOps, but based on his knowledge, which obviously not like top notch because that's why he's here, but he did a good job on the group 8 week 4 task. So what stood out for me was the fact that for the exercise we did mention that there was a bit of an extra. So if you're able to get the work done, which is spin up 3 machines, get your fruits and vegetable things displayed. But there was a bit of an extra there that if you could then create multiple instances where you have them in different availability zones and then use a load balancer to kind of, balance the workload or the traffic across 2 availability zones. He was able to do this, and that kind of, for me, it was a bit of an effort. So that has not gone unnoticed. I'd always try to check each and every task to see how much effort people are putting into it. So well done, Ahmed. And again, some of these tasks may look simple for some people and it may be hard for others. But the important thing is you have to realize that these are all building blocks. So this is why it is important to do them, even if you think you know them. Because as we are kind of laying the foundation, we're gonna keep building on this. And if you kind of miss a step and you just assume, oh, I know it. When we start doing the things a little bit more advanced, you might struggle. So it makes sense to do them. Anyone not doing the exercise, honestly, it's a waste of time being in this class. It's a waste of time because DevOps itself is hard enough. So if you would not practice, then you're just wasting your time. We've said this many times. I kind of emphasize this. Right. So thank you, Med. Well done. I think also I will mention Kunle, although I think his work is not finished, but I think he's starting to he put some effort into the Group B task, which is the customer exporter. So why I want him to focus more is not on the Terraform B, more on what's it called, um, not
Grafana.
basically on the develop, not the Grafana, more on the platform as a service, SRE kind of work, which would be the code. The code has to be spot on, and the display should almost match what we see on the UI. I think I already mentioned that. So well done. Okay, without much ado, we are going to start today's topic, so which is infrastructure as code. I am going to prepare some foundation so that we understand what we're doing before we kind of jump into it. You're going to permit me to do some diagrams and some illustration. Okay, so let's start. So where are we? Right. So I'm just going to lay some groundwork as to where we were and then kind of make a case for why we need what we're going to learn today. So draw.io. Right. So while that is loading, we've made some good strides in terms of let's cancel this. We've made some good strides in terms of where we are. This is almost week 5. We've been able to play with a version control system, which is obviously using GitHub and Git as a way of gaining access to GitHub. And we've been able to check code into our repository. We've been able to download code, be able to create branches, etc. In terms of DevOps and how things work, the version control system, as we have said, is one of the most crucial things that needs to be learned, because that is how you will manage the state of your code and sometimes the state of your infrastructure. Code in the sense of maybe a developer is writing some things and pushing it into a repo. With the version control system, you really don't run the risk of mistakenly deleting the code. Yeah, it has to be a deliberate act of sabotage for you to lose a code, because even if you delete something on your system, you're always going to find a version of it in your repository, maybe in GitHub, maybe in Bitbucket, whatever repository you choose. So you don't really run the risk of mistakenly deleting an artifact, because in as much you've committed into your repo, it's almost there like almost forever. And that is why version control system is important. It's also important because with the version control system, you can have different versions of that artifact in your system or in your repository. So you could have like a version 1, which maybe a developer is working on, and a version 2 where somebody else is working on. Then you can then converge those branches or those work into one a group of work onto one solid one, which probably will be your main branch. So we've looked at this, and that will be a continued effort, because we will build on that and we will look at advanced side of things as far as version control is concerned. Also importantly, what we've also looked at is how you would manage infrastructure in the cloud. We looked at infrastructure as a service, as a concept, platform as a service, as a concept, software as a service, as a concept. And we try to kind of show what the differences are and why you would need one or the other, depending on scenarios, such as your knowledge base, cost implication, time to market, etc. So these are all the building blocks that, it's important to know them. And also it would help you in your discourse. when the time comes to start interviewing for DevOps, SRE job opportunities. The reason why this is important, understanding these theoretical side of things and also to basically practice using them is mainly these days now, when people go for interviews, what interviewers do, which I think is a bit crazy, but it is what it is that they do spin up their AI system to listen up on what you are saying so that they are not bamboozled by, you trying to kind of deflect questions or sort of playing smart on them. So they allow an AI system to listen to the interview, and the AI system will basically judge if you have done well or not. That's the direction of travel these days, to be honest. So if you know your stuff, maybe in terms of practical use of tooling and systems, but you're not able to adequately articulate what you know, you might not get past the interview stage, which is unfortunate, but that's the nature of the beast these days. So it's important to not only understand this concept, play with them, but also fine-tune your theoretical knowledge of them and being able to articulate and explain what you're doing. Some people know stuff, but they can't articulate it. The world we are going to now is the world of little, small, not so many jobs out there, little jobs, and everyone is going for them. So you have to make sure all the toolings and the know-how you have are sharpened up and working for you so that you can stand a good chance of surviving this, not so coming too often interviews these days. So if you're able to get an interview, you want to make sure you have dotted all the I's and crossed all the T's to be able to nail it. So it's important to understand the theoretical side of things. So we've looked at, going on your cloud platform, knowledge, AWS, knowledge, Azure, where you can spin up a virtual machine if you want to kind of play in the IaaS world, where you basically create a VM. And on that VM, you can then repurpose this VM to whatever service you want it to run for you. So you could repurpose it and maybe as a database server or a for database service. You might repurpose it for application service. You might repurpose it for web service. You might repurpose it for email service, etc. We did mention that a typical machine, what makes is a web server, a mail server, an application server, a database server. What makes it such is the software you run on it. Every VM is a machine, or every VM is a machine, and every server is a machine. What makes it serve a service is the application you install on it. So you can repurpose a machine to be your mail server, web server, etc. So the software you put on it makes it such. So if I call this machine now and I basically put something like Exchange on it, maybe MX Exchange, or a mail server tool on it. This then becomes my mail. This then become your mail server, and you can basically create email addresses and whatnot. And then this becomes your own mail.admed.com, and then you can begin to create account for people. Foley at mail.admed.com, Cynthia at mail.admed.com. You can literally set that up yourself. Just install a mail server on this, register it as a mail exchange server, and then literally use the tool on it to create a mail server. It's that simple. Of course, people don't want to go through that stuff, stress, so they will use what we call SaaS, software as a service, where you just go on the platform and then you create your own domain and create your own email service and use it. So, but you can literally build your own from scratch. That we are sort of exploring the power of infrastructure as a service. You can make you do anything. But obviously, for you to be able to do that, the challenge is that you have to have the know-how of doing it. I was speaking to an audience a couple of days ago, and I was trying to use the analogy of an orange to explain IaaS, Virtual as a Service, and then and PaaS and SaaS. So So essentially, so if we look at this, I'm just gonna, and sorry for repeating this. I think the more we do this, the more we understand it. So if you look at infrastructure as a service, this is the bedrock of everything. Everything starts from here. So these are all VMs. You're just provisioning infrastructure. I'm saying VM, it might not only be VM, it might be storage, it might be load balancer, and all those basic ingredients of a hardware system. But in most cases, it will be a VM. So if you can liken that to like when I say VM is a virtual machine, you can liken that to concept of orange, so an orange fruit, and with an orange fruit, if everything starts from orange. Say you want to maybe use make a juice from orange. So you want to do that an orange juice. Of course, you can go to the shop and just get like maybe Ribena orange juice or some orange or some branded name orange juice. But also you can make your own and say, okay, I'm gonna be at home and I'm going to get like a blender and just gonna blend it and use it. But everything starts from orange. An orange, you can make a juice, you can eat it raw, and you can go all the way. And if you are interested in a branded orange juice, you can buy one. So the point I'm trying to make here is, let's say your infrastructure service, you're looking at an orange juice. Everything starts from there. If you are interested in taking having a beautiful orange juice and you don't want to go through the stress of buying the fruit, peeling the fruit, blending it, adding ginger, honey and what have you, you can go buy a branded one. But when you buy a branded one, which is good to go, the problem you're going to have is that you're going to be limited to what the manufacturer put in there. Maybe they don't do honey with oranges. Maybe they only do like maybe ginger and something else with the oranges. Whatever the package is what they use. And that is SaaS. SaaS is good to go. So if you have a platform that uses SaaS, which is you want to like do something and you want to go quick, you go for SaaS, but you're limited to what they provide you, the version of an application, what have you. So in the case of maybe you building a website, you can use something like WordPress, which is good to go, but you're going to be limited to the version of the WordPress, the version of maybe the database they use, etc. And that is you getting a ready to go orange juice branded one. In past, so this is somebody who is maybe your neighbor who doesn't mind going to the shops to get the oranges, peel them, and just blend them, but it doesn't have the packaging. It just blends them and they say, okay, hey neighbor, I've done some oranges. I'm gonna be selling them for very fraction of an amount. They are fresh, they are raw, and you can buy them. But the guy has gone through the hoops of peeling out the outer layer of the orange, blending it, maybe even removing the bits in the orange and filtering them. And that is PaaS. PaaS is not as good, it's not as ready to go as SaaS. So, but it's better than, not better, it's more refined than infrastructure as a service. So this is the sort of the locally blended orange juice, which is not totally branded. Maybe you have to then get the juice and then add some orange to it yourself to get what you need. But it's a bit more refined than just getting the orange. And that is PaaS. In this case, if you're looking at things like a database engine that has been set up for you, like maybe Aurora database, MariaDB, that all good to go, been set up. If you were in the SaaS world, you would have to spin up a machine yourself and do the installation yourself. But maybe somebody has done that for you, and that would be PaaS, which would be a service sitting on a VM and as with a specific software on it and tuned to do your work. But with PaaS, you still have to do some extra work to get to your finished end product. So we are getting this concept, we are understanding them because they are the building blocks we are going to rely on. And we've done a lot of infrastructure as a service, spinning up VM, configuring them as web server, putting Nginx to them. And last week, we looked at also putting on Python, which makes our infrastructure as a service. In this case, we did put, we had Nginx. We then had Python, which makes it an application server. And then we also have Java. So the Nginx was literally sort of feeding off the Python application server and feeding off the Java application server. And this is all infrastructure as a service. In another word, instead of spinning up Python and spinning up Java, we can go on the cloud platform and look for a PaaS solution that already has Java, everything installed and good to go, instead of us having to do all the manual installation ourselves. There are PaaS options on the cloud that doesn't require you to be spinning up a VM and putting Java on it, which would be faster and maybe a little bit more expensive than you spinning up the Java yourself. Ultimately, you have your own application, which is the Python and Java code. Python code. And the Java code. I can just make them a little bit smaller and make them maybe green and maybe purple. So the Java code was deployed on the Java platform. The Python code deployed on the Python platform. It is not enough to only have a Python ready VM, which is running Python, or Java ready VM, which is running Java. You still have to put the code that a developer has written to make it do the exact where the business rule or the business or the objective of the machine of the service is being implemented. If you recall, in our case, let's see, vegetable market, we had the Python code living in Python, which is where the implementation of vegetable pricing and sort of the food pricing is implemented. And also we have the same for the Java code where the Java listing pricing is implemented. And this is the code. So without putting that, you have to find a way to get that code on the platform. You don't want to put the Java code on the Python platform and vice versa. So you have to make sure the right code go on the right machine. And then your web Nginx, which is the web front, is able to feed off these two systems, right? And then the way we kind of set this up was obviously going on, in our case, I think there wasn't any Azure submission last week. So I was hoping that we will have some people using Azure. But I don't think we have any for last week, but you could have gone on your platform, maybe on AWS or Azure and spin up these three nodes and then configure them. Let me log on. Can't. Yes, console. Fantastic. So on AWS, obviously it would mean creating those machines, installing the right stuff on them, and Bob is your uncle. Of course, on the Nginx one, you put Nginx application. The Python one, you do Python installation. On the Java one, you do your Java installation. But the way we've been doing this up until now is to do basically usually a manual setup. We'll click on the EC2, we provision it, and then we'll make things begin to run for us. So we'll go to EC2, spin up a system, and then do some installation on it, etc. And then we kind of upgraded from there instead of every time building an Nginx platform or building a Python platform or building a Java platform. we graduated to building what we call an image. In the case of in AWS case, we call it an AMI, Amazon Machine Image, which is just a pre-prepared system that has a specific software installed on it. The objective of this is to ensure that you don't have to do your manual setup all the time, maybe installing Nginx, installing some services or tools you need on the system. You can prepare it, pre-install it, and then use it much later. And this is good because it reduces your time of creating a VM, a machine, because you already prepared the machine, and then you can then leverage that to create your new VMs. The challenge with this approach, obviously doing it manual, is that first and foremost, this is not how it's done in the enterprise. Because what we've done up to now is we will go on the platform, spin up a VM, install it, and capture it as an image, which we did, I think, 2 weekends ago. And then we just freeze that image and then we use it up. In the enterprise world, it's not really done like that. It is managed using your version control system. What do I mean? In the enterprise world, everything is encouraged to be managed as a code. What do I mean by that? The creation of your VM and managing the state of your VM, ideally, they want it to be codified. What do I mean? The way you will create your VM, which is you go on the platform and you do a couple of clicks and make it happen, is not the way the enterprise encourages. Enterprise encourages managing even your VM creation using code. So if you look at it, things around, let's close this out. So things around the creation of maybe your base image, which is then used to create a VM image, and then subsequently using that image, they want all that to be managed as code. So I'm going to give us a vivid example, and then we will see how we manage this as a code. So the entire premise of this weekend class will be infrastructure as a code. How we are going to move from manual spinning of machines to actually using code and basically leveraging version control system to not only keep our code, but also manage the state of our infrastructure. Okay. One of the important reasons for using code is it just reduces the time to build infrastructure, because you can if you're going to be timing how long it's going to take for you to do a couple of clicks to create 10 machines and basically running like a few line of code to do the same, the code will win 10 times, 10 times out of 10. Using code will be a lot quicker. And not only that, using code would ensure that there's consistency in how you create stuff. And also using code allows you to track what is being deployed, because somebody clicks something, you don't know what it's done. But if you are using code, you can always go to the repo and look at what is in the code and what you are trying to create on an environment. So that is why using of code is actually encouraged. And what do I mean? So let's say, for example, I know we've seen this many times, but I just want to use this to kind of illustrate what we are going to do and how we're going to manage it. So say, again, we are spinning up a machine that runs a web server, Nginx. We've done this many times. So I'm going to do it again one more time, but with a bit of a twist. So what I want to do is what we've done severally. I want to create a base image that has Nginx and maybe Git on it, so that when I'm creating subsequent machine, I can use the image to then create some other machine in future. So in this case, say I want to create a machine that has image running. So they may be running Nginx. Nginx. Nginx plus Git installed on it. So from this image, maybe I want them to provision 3 systems. Duplicate. So I want to spin up 3 systems, basically, which from this base image. Well, let's make it just 2 systems so we don't go crazy on this. So I want to first create a base image that runs Nginx and Git so that from that base image I can create subsequent VMs, virtual machines of that image. For this to happen, first, I need to first and foremost spin up an image. First and foremost needs to spin up a VM that would have Nginx and Git installed on it. I would then harvest that I would then harvest that and create an image of that. Of course, after that, I can then let this one go and then keep the image. And from that image, I can then subsequently create image a little bit quicker using the base image I already created. Okay, we are going to bear with me, please. We are going to basically see that in action, which is obviously something we've seen before. So I'm just going to do that manually first, and then we're going to see how we're going to use a special tool for that to make it happen. So basically for this weekend, we're going to be looking at 2 special tools. One is called Packer and the other is called Terraform. We're going to see what role each plays in this scenario. So please bear with me. I know it's a bit slow, but it's important to get the basics right. And then everything becomes a lot smoother. Okay, cool. So now what we want to do now is we want to make this a reality. So we want to spin up a machine and harvest that machine as an image, and then from that image get to other machine basically created. So that's the plan. So without much ado, let's get to it. So we've done this many times. I'm going to be showing us a little bit of things that we probably have not been paying attention to deliberately. I've not really been stressing those things, but I'm going to be calling them out gradually. So we're going to launch our instance. In this case, we just want to create a base VM that we can use to create our base image and then delete that VM and then use that base image subsequently. So we're going to call it, we can call it Nginx Git throwaway. Because we're going to throw this machine away as soon as we get the image that we need. Okay, so we make everything simple. I'm going to be calling a few things out, deliberately. So AWS, we are still going to use our what we call the image. We're going to use the base image that AWS provides for us. So Amazon Machine Image, AMI. So we're just going to use this image. Now, when you choose the image you choose, obviously would depend on what you want to do and your experience using them. So in this case, we are still using Linux. We're choosing Amazon Linux. Any image you choose here, they have like a unique identifier that identifies those image. So in that case here, we are choosing Amazon machine image. There are a lot of options you can choose from. So this is kind of 6.1. You might want to change it and then use some others, some for deep learning with NVIDIA CUDA, CUDA software on it and so forth. Obviously, the one you choose, obviously then depends on there's a cost implication in choosing what you want to choose. So you have to know what you're doing and then select the one you want. Obviously, for all of the mill stuff that we're doing, this AMI should suffice. But the point I want to make here is any AMI you select. So if you look here, there's a number, there's an ID that uniquely identify the AMI you select. So if I say I chose Ubuntu, watch here. Okay. see it's going to change. And that is the AMI, the base image. So this one that we are basically creating first, which is a throwaway, it's based on also an existing image that's been created, another AMI. So in that case, now we want to use AWS, Amazon Linux AMI. And that's what we're gonna, that's where this VM is gonna be based on. So AMI, every AMI has a unique identifier that identifies them. So obviously we're gonna use this one. Let's change this. Okay, I don't know what that is, but yeah. So you can see now these AMI changes, and in this case now, this is the one we are using. We're gonna pick that up and let's copy it. And that is the AMI that is being used. And that is one that this is just like a parent, a child. This child is an offspring of this parent. So when this is running, it will be off, it will be based on the DNA of this one. Okay, potentially now there's going to be a new child that will be an offspring of this. Obviously, this then become the grandparents. You can then see the progression of things. So this is the base image. We're going to spin up a VM and then we'll put some extra thing on it. So this will just be, this is a version of this, but with extras. So let's do that. So now we look at that, and that's the base image that we're going to use. And then we will say, okay, and you can see that that is here. Then the instance type, how powerful is going to be our machine, how much CPU VM is going to have. This is what we are describing in the instance type here. Of course, there are many types. We've always been playing with T3 micro, but there's different type. And when you select it, would have implication how much it's going to cost you. You can see now this is about 0.08. If you're using, depending on the AMI you use, that then determines the pricing. So I think the cheapest is still the on-demand based Linux-based image, which is 0.0063 per hour. So all the one you choose, the cost implication. And then we would select a key. It's terribly not important now because we are creating an image that we're going to throw away, but let's still kind of keep things consistent. Select a key, and then in network, we don't really do much here, but I think basically things going on here, that's what I'm mentioning now. So, and I'm going to expand on this much later as during the course of the program. So when you create a machine, that machine needs some fundamental infrastructure to run well. So a machine is created in a particular, in an ecosystem. So if you create a machine, say we provision this machine here now, this machine needs a few things to run and run well, which we have not really been stressing too much up until now. I'm going to expand on that, touch it a little bit, but we expand on it much later, because those things will become apparent and useful as we kind of go along. This machine, first and foremost, needs storage. But when you install stuff on a machine, you have to put it, it has to exist somewhere on that machine. Okay, so there is two types of storage, okay, that the machine uses. There's something we call block storage. Okay, so let's keep this, let's keep it nice and simple. So I'm just going to talk about block storage for now. But in the concept of AWS, so block storage, what another thing it needs, is terrible, that is important, is an NIC card, network interface card, NIC, which is for networking, NIC. Because NIC is how the system is able to communicate with the rest of the world. Okay, so, and not least CPU, memory, and whatnot. So CPU, central processing unit, and memory as well, which is RAM. Memory. Okay. So these are the basic things that I need. Of course, there a little bit more than this, but in kind of, not too oversimplified. But these are the important things I need. The block storage usually in AWS world is it probably exists outside of the machine. So, but they at the time they've created the machine, they would connect it to the machine. The reason for that is if you delete the machine, you don't want to delete the block storage by mistake, except you deliberately choose to, because this block storage can be detached from a machine and attached to another machine. So whatever you install on this machine potentially can be saved. But we'll come to that later, but don't worry about this too much for now. Network interface card will allow you to potentially have communication with other machines and maybe the rest of the world. For example, let's say this machine was duplicated, maybe running something else, it would have its own NIC card, and that is how machines are able to communicate. Okay. With a network interface card, it will not be possible for machines to communicate. And also, if you're coming from external, the way you're going to be able to communicate with the machine is because the machine has a network interface card. Without NIC card, there will not be any IP address to connect to, and you will have a machine that is basically cut off and siloed that no one is able to talk to. The network interface card is important, and that kind of defining all the networking sort of landscape that the machine needs to work with. In terms of networking, I'm going to also basically just talk a little bit about it, and I'm going to be showing us some things. So in networking, there is 3 things. So this is the NIC card. The way it works is this, okay? Your NIC card, network interface card, or even your networking structure, it would operate in what we call a network group and a sub-network group. So when you're creating a network and you're trying to get your machine to have an IP address, there's it has to be the network address is going to must belong to a big network. Okay. And let's see. Okay. And I'm going to repeat this much later. So if you're not really getting it, don't worry too much. Let's make this green and let's send it to the back. Send to back. Okay. Okay. Bear with me. Send to back. Okay, cool. So your network interface card, which is what the machines use to, allow communication, is basically broken down into 3 layers. The first layer is basically the big network. Let's call it the main network. Okay. Which are the top level one, which is this green one. And then you have the subnetwork. And then you have which is this one. This is the main network. This is the subnetwork, and then you have your NIC. It is like you have like a hierarchical structure. Maybe you have country, state, and town. A town would be in a state would be in a country. So you then have a country with many states and towns. So you can have a country, state, and many towns in the state. And you have countries with many states. So you have a network with so many subnetworks, and obviously network created in those subnetworks. In the cloud nomenclature, your subnetwork directly maps to your data center. So the main network is the main network. It's almost like your region. So, but the subnetwork will map to data center. So Usually your subnetwork would try to mirror your data center. It's going to be more on this later, but for now, let's just assume that for your network to exist, you have to know a subnetwork. You can't just create a network in isolation. You have to base on a subnetwork, and the subnetwork is based on the main network. Okay. And those are the things. So when you create your system, you need a network which has to be in a subnetwork, and the subnetwork is in the main network. So you need memory, you need CPU, you need storage. Okay. And you don't define all that at AMI level. It is why you are creating the machine that you need to define all that. And that is not basically carried in the image. Image just define what is installed in the system. When a system is created, that is where you determine all these all these options that you need your system to have. So that is not captured in the AMI. Just let's remember that. So without much ado, we want to create a machine which is Nginx with gate of AMI, the base AMI. That will be the if you like the main parent from which this gets stood up. And then okay, get some noise there. Let's find out who the culprit is. Mute. Okay. All right. So and then we would spin up Nginx and Git after we created that machine. But as we are creating the machine, because the machine needs to be instantiated, we have to define all this. They're not terribly important, but let's keep an eye as we are kind of creating the machine. So now we've talked about the AMI, we've talked about the type, which basically determines the capacity of the machine, how strong it is, CPU. The one we chose now, we're choosing two CPUs and one memory. Essentially, it's gonna have two CPUs and a gig of memory. That's what we're defining. And 1 GB memory, which is just a gigabyte of memory. That's what we're defining here. Okay. And then we kind of go on and we talked about networking. Okay. This is the main network. It's almost like your Nigeria. So let's look at it. So I see this when this machine is going to be created, it's going to be created in this network. And then you can specify the subnetwork that you want to choose. The subnetwork will mirror a data center. We are saying go with default, or we can basically choose and say we want to go with this subnetwork. Let's just choose whatever. So this subnetwork, you can see it's like the state in a country. This is the main network, and this is the subnetwork. And you can see the here, this subnetwork is based on this main network. Okay, and this is this subnetwork your network will get created, say IP address creation. So that means when this machine is stood up, your network creation will be of that subnetwork, which is density of that main network. These are very important things to put in to bear in mind. We're going to look at networking at some point. And then your security group, which manages what you're able to access on the system, get created off that. Okay, and then you look at your storage, which is this bit. How big do you want your storage to be? We never really touch this. We are saying it should just be 8 GB, 8 gigabyte of storage. What a lot of people confuse storage and memory. So memory is transient. So when the system is operating, it will put the software that it needs to play with at runtime in memory. But as soon as the task is done, the job gets deleted off the memory, or maybe you restart your system, anything memory gets wiped out. Block storage is where the system will persist data. So you keep data for the future so that it doesn't lose data that gets kept in block storage. The processing of the things on the computer happens in memory. So this is almost like your bag where you keep books, but you can bring that book out and then maybe do some calculation on the book. So when you're doing the calculation is here, but after finishing your calculation, you need to put your book back in your bag. Otherwise, you will lose that calculation. So the calculation you do obviously, happens, After you're doing what you're doing, using the analogy of bag and book, the book where you're doing your calculation has to be kept back in your bag. If you don't do that, you will lose the book, and then you have to go get like a new book and then do the calculation again. So when the system does what it needs to do, it happens in memory. But if you want to keep that state of what is done and keep it forever, you have to pass it in a block storage. So that's the difference. So this is almost like an operating table where things happen. After it's done, you need to persist it, and that's how a system works. So that's the difference between the storage and memory. Okay, and all those have to be defined, and we've been glossing over that up until now. So there's still more to come, but just bear those in mind. So that is all summarized here. And then we will then proceed to create this machine. Obviously, when we create it, it won't have Nginx and Git. It will just have whatever else comes with Amazon AMI default. So we'll spin up this machine, and then we will then slap Nginx and Git on it. And then we will then harvest as an AMI, and then we'll kind of create two machines of it. We've done this before. We just kind of pay more attention to it now because we are going to move from using manual clicks to using code. Okay, so this is all done for us now, potentially. So this is the machine, and then we can connect to it. So we're gonna connect. So we connect to the machine. Again, remember it's our little throwaway machine. So if you go instances, that's the machine operating here. It's running. This is going to be something that we'll create an image of, and then we'll delete it. And then we'll have it as an image. Okay, so this machine is there now. So again, looking at the plan is to install Nginx and Git on it, and then destroy it. Okay, so what we then do is we just install Nginx and what's it called, and Git on it. So one thing you can quickly do is you can just do sudo yum update just to make sure everything is nicely updated on it. Sudo yum update. So everything on it is updated to latest. Just do that. Okay, we got a bit of a noise there. Who is Wab? That person is just on meeting and just distracting us a little bit. Okay, so the update is done, and then we then do sudo yum install Nginx, and it will say yes. So everything get installed quickly. Nginx is installed. So we want one thing we also want to do is enable Nginx, and then start it just to make sure it's all working nicely. Okay. So sudo sudo systemctl enable. So what this does is it would ensure that anytime when the system comes up, Nginx will start by default. This is what this means. It's enabled, and then we can start Nginx. If you don't do enable, anytime the system goes down, or when you spin up a new version, it will not start by default, and then start Nginx. Of course, this is all good now. If you just to test it, look at host. You should get something nice running. So we got it now all figured out. It's cool and it's working. We can also kind of make it a little bit interesting. We can do something like, the file here, there's a file here. If you remember, the file is in USR, share Nginx, HTML, and there's an index file here. Index. This is where this file is, which is showing what is showing here. If you cut this file, you open the file, this file. Let's see, where did I do the cut? Cut, Okay, pardon me. Okay, this is a cat, which is opening the file. This file, it is what gets shown. The content of this file is what gets shown when you browse the web page. Okay, now this system is created. I can override that file and create a new file, which we can do quickly. I can say sudo vim just to edit the file and edit the file and just put something else there. And then we can do something like Google. You can see that's the HTML stuff there. Then we can just delete everything, just do something like just delete everything, and then we can do something like this. Just do H1. Don't worry about this, it's just me messing around. Hello. Um, template. Template. And exclamation and plus H1. And that's it. So I do that. And then I can do another car. You can see now this is what I get when I try to browse that endpoint. This is all kind of nice and good. So when we do all this, obviously, if we harvest this image now and then we create some more images of this image, this is it's going to inherit. So the other thing we want to do is we want to sudo yum install Git. Yes. So we're gonna put Git on this machine as well, and then our mission is complete. So Git done, Git version, just to check. Okay, Git is good. So if we look at in terms of our mission here, so we have fulfilled our mission. So we have Git and Nginx on the mission on the system, and then we can harvest our image. So what we do is we go to the machine, we've done this before. We go here. This is the machine, the throwaway machine. And then we go to action, I believe. And then you go to image and template. You just say create an image. So we're gonna create an image and we're gonna call it Nginx Git image, something like that. And then we'll create it. We can create a tag to kind of give it a name, but let's not worry too much for now. Then we create that. So that would create that image for us. So if you go to AMI, it takes some time before it's ready. Okay, this is the one I created a long time ago. So this is the one that's being prepared. So let's just tag it properly there. So this is coming. I think I had this a while ago. Let me just detach. Let me remove this one so it doesn't confuse us. To register AMI. Okay. Pardon me. This one, let me just remove this one, is deregister. Action. Yeah. Okay, so let's remove that one. So this is the one we just created, so we don't get confused. So refresh is still sort of pending, it's still being created, but it's giving us an AMI ID that we can use. So if you go to this diagram now, so this diagram now, this is the new image that we are creating of this. That's the image that's being created. There we go. Okay, I think it's almost ready. Okay, we're gonna kind of hope that it's ready. So I'm gonna look at this AMI, and that is the Nginx Git image AMI. So from this image, as soon as this is ready, we should be able to delete off the instance because we won't need that instance anymore. And this throwaway, we can then delete it as soon as we have this image ready. Still sort of pending, it takes some time to do. So while that is going on, we will delete that instance when it's ready. But what we can do is we can begin to create the other two systems that will be based off the image. So we're going to create node 1 and node 2. Okay, remember that we are only using the manual approach, which we are going to move away and from to create these instances at this point. So we will then say, we go here and launch new instance. Okay, let's just refresh instance. So we are going to create nodes. Let's just call it nodes. Let's call them nodes, and we can change the name later. Nodes, because I want to create two at a time. So now the image you're going to use is not going to be this base image. We won't be using this one. We're going to be using a better one, which has engineers and get it out started, which is the new image. So obviously this is still based on this, but with extra. So this is the image we're gonna select, which is the one that's just been created for us. And yeah, this one. If you see, that is the AMI. So let's keep note of that. I want to copy the AMI cancel. I want to get the AMI ID. So which is that one. Let's copy it. And let's play here. That's the AMI ID here. And that's the one we're going to use, that one be used for this ones. So we go here. Actually, we go here and say we want to create nodes two. Let's say 2 nodes. And then we'll come to this AMI, but we won't choose the default one. Go to my AMI. Owned by me. You can see that here. And that's the one we choose. Okay. And that's the one chosen for us. And then everything else remains the same. So we'll choose the key that we want to choose. We're going to create a security group, but let's allow HTTP traffic to come in so that we can test this off a web page. And then we'll keep everything else the same, but we'll make the instance 2. And then we will launch. And then see the network, everything still remains the same. And then we'll launch. Okay. So I think because the AMI is ready, this we go here. We can delete the old guy, which is this one. We don't need it anymore. We can go instance state. We can just terminate this one. And we just say terminate. And then this should go away. And then we only have the other 2 nodes running. So we can then call this one node 1. And then we can call this one node 2. And then we have our node. So essentially we have created these 2 nodes. If I can find them. And they are based off this one. So if we go on them, if we don't work well, obviously this one is gone for life. We won't be able to access it anymore because it's dead. We've deleted it. So let's delete that one. And we don't need, let's just close this one. So if we go to node 1, in fact, just to be sure, without even logging to it, we should be able to access the web page. So if we go, let's get the public DNS and then open a web browser and then we'll do HTTP. That should work. Okay, hello from TechNet on one. And then on the other as well, which is the second one, we should get hello from TechNet as well. So which is the other node, HTTP. Should get hello from TechNet as well. And if we log on them, let's just log on one, just one. Connect. We should be able to find, what's it called? Git running on it. prove we've done it well. Just say git dash version. You can see Git is running on it. By default, your Amazon image doesn't have Git, but because we are leveraging that image, everything is good. So you can see that, we've pretty much done all the work. The only fly in the ointment, as far as this task is concerned, is the fact that all these were provisioned using manual means, which is not what will be expected at enterprise level. But the approach we've taken is typically the approach that things that, anyone would take to do the work. It's just that we've done it the manual way. In an ideal world, you want to do this programmatically for the reasons that we've highlighted previously. So how do we do this programmatically? So the key thing here is the generation of the image first and foremost. How this image was generated, obviously, we know the history, the AMI created, slap some things on it, and then boom, boom, we then harvested that image, and then we have this image generated, and then we then subsequently leverage it to create what we created. So that first process of getting the image is what we are going to first and foremost try to automate. The automation tool we're going to use is called Packer, and let me introduce you to Packer. So Packer is a tool that allows us to connect to a platform such as Azure, such as AWS, Google Cloud, define what we need installed on a VM, and the action that we want to take on a VM, specifying the region and what have you. And then what Packer does is Packer will look at what you want to package on the system. He would go to this to the cloud platform. He would basically spin up a VM, do all the installations as we've done, and then generate an image of that installation, and then subsequently delete the VM. Literally what we've done manually is what it's going to do for us. But Packer will not spin up these two instances for us. It will only generate that base image. So Packer's work will start from here. So if we use Packer, Packer would do this, would specify the AMI you want to use. And then of this AMI, it will generate this. So you would have told Packer to please install Nginx and Git. And then Packer will spin up this image, install Nginx and Git, and then create this, and then Packer will just delete this. Literally what we've done, but it would not go to this extent of now spinning up, instances. Packer's work stops at the AMI generation. Okay, so let's look at that. Let's look at HashiCorp Packer. So HashiCorp Packer automates image builds. So we go there, and this is the block. This is the kind of the welcome page. Accept all. It basically tells you what Packer is about. And then you would specify the kind of platform you want to use for your work. No list. Let's see. There's a bit of a noise there again.
Let me go downstairs. Let me bring some notes. Let me prepare.
Okay. All right. So we look at it and say, okay, Packer will connect to AWS, Google Cloud, Azure platform, do all those beautiful bits for us. And then it's all automated, it's beautiful, and that's what we're gonna look at. Okay. And that's how things are done by the big boys. So let's look at that. So first and foremost, you will need to install Packer. Let's see how it starts. Let me see if there's something I can share here that would help us real quick. Documentation, tutorials, maybe. Packer. Let's see. Packer. Okay, getting started. Browse Packer. Okay, so let's see. Anyway, I wanted to show us a Packer run for a Packer task. The simplest. Okay, let's not worry about this. Let's kind of do our own thing. I wanted to show you how it all starts. So in our case, let's not worry about what they have, but that's their own page. So it's Packer HashiCorp. And those are the maker of Packer. So Packer is very popular for creating images. Okay, it might be an interview question, or how do you stand up your own VM image, having a few things installed on it, and then you can say, okay, I start my journey by creating my version control system where I will specify how I'm going to create my my VM image. The tool I use is Packer, and I will have all my code written in sort of written and saved in the version control system, and I use Packer to implement that. So what do we need to do in terms of our journey? What we need to do, first and foremost, is we're going to start using Packer. Okay. Okay, so to start our journey, let's go on, and we want to manage everything as a code. So it makes sense to so let's do is it makes sense to create a repo, GitHub template. So we're going to create infrastructure as code. So let's go to template and basically create a repo. So we're going to say new. Let's call it class 2025 infrastructure as code. Let's do it as that. Okay. Let's then say, I'm not going to put too much here. We're going to do that later. So we're going to create a repository, just make it nice and simple. And then, so but then because I'm going to be doing this off my machine, so I need to get this, but let me prepare my machine first, and then we can play with our image. So my machine, I will use Visual Studio Code, which we have been using. Okay, bear with me. Let me set that up real quick. So I would come, so my machine, I would just do something like, let me close this out. Okay, let me clear my screen here. So I'm gonna go to my temp system. I'm gonna make a directory. I'm gonna call it class 9. Class 9. I'm gonna cd to class 9. And I'm then going to pull this down. Okay, SSH, copy. I'm gonna do git clone. I'm gonna clone this. Okay, the repository is empty. We know that there's nothing in it. But we go inside, and then we will then do code to open Visual Studio Code. And then we would have the Visual Studio Code hopefully loaded. Yes, it is loaded. Let me bring that out here. So we'll see it. That's the guy there. Okay. Let's see. Bear with me. Okay, let's close out this cursor thing. Okay, so that's it. Look here. Right. I've opened it up. Let's go back. Let me just go back one step and just open it here. So I believe we'll see that folder. So I'm gonna go code. I will open it here. So in here is where we have the directory. So let me just do code to open it. And yeah, so at least we see class 9 here, so we're not lost. Okay, and then let me just find it. I'm still getting used to this new update from Apple for this Mac machine. It's beautiful, but it takes a bit of getting used to. Okay, and it's just throwing me off a little bit. Okay, cool. So this one, I think we have too many open. So I'm gonna put it somewhere here. Okay, let's put it in code. Yeah, so that's it. That is it. That is it. So this one is this one here. So close the welcome page. Right, and then we have it here. So everything is sort of empty, and that is where we play. Before we go any further, because we're going to be using Packer for our installation, it's important to install Packer before we write any code. So Packer installation is very, very easy. So let's go back. So I will say, just basically say, install Packer, install HashiCorp, Packer. Yeah, not type the web, but install HashiCorp Packer over here. So it's not very difficult. If you're on like Mac, just tap root tab just to basically install the set up the repo and just install it. If you're on Linux, that's the approach. If you're on Solaris, and where is good old Windows? Okay, and this is Windows. Just download and install. It's very simple. And then you put on the platform here, just for everyone. So you're gonna need that. You're gonna have to install it first. Let's kind of make sure we have it. Okay. Okay, so let's share with everyone. Okay. Right. So I've installed Packer. So you just, if you're on Linux, just do that. I'll share the link with you if you're on Windows. It's very easy to install. So after you've done your installation, you want to make sure it's working. You just like, let's see, just say, get my output file. So ls, and then let's go into class, which is this folder. Let's go in there. Let's just say we've not done anything. You just say Packer version, just to make sure it's there. So we got Packer version for the 1.14.2. That's the one we've got. And then we can begin to start our Packer journey, essentially. So what we want to do is we want to start writing out the code that will basically replicate what we have for creating the VM. So I'm going to create a file here. Okay. I'm going to create the file. I'm going to call it maybe AWS. Let's call it Nginx Git. Let's call it Nginx Git. We call it the pkrfile.pkrfile.hcl. Okay, let's just give it a name. So usually just keep your Packer file as Packer file HCL. Okay. Okay, right. So then we begin the code. So the way it works, I'm gonna start simple and I'm just gonna and then we'll make it better as we kind of go along. Okay. Right. So we then do basically we start with saying Packer. And then we open bracket. So what the first thing we're gonna need is we're gonna set up the required version. Usually is this is what we are doing here. Because Packer can be used for any platform, right? So we want to basically specify the minimum version that we're gonna use for our Packer. So this is not terribly required, but you can put it there anyway. So you can say required version just to make sure you're using the right version, should not be less than should be greater than, let's say, it should be version probably should be greater or equal to version 1.9.0. So you are making sure that when anybody is running this Packer to get a consistent behavior, make sure the version is not less than 1.9. In that case, it would work because our version is version 1.14. So we are trying to kind of lock down the version that folks who might use this would use. So that's important, that you don't have erratic behavior because some are using the old version. So if that version that doesn't measure up to this, Packer will fail. The build will fail. So obviously Packer works for different cloud platform, AWS, Azure, etc. So you have to specify what you want to use it for, and that's what we call the required plugin. So we want to do the plugin we want to use is for AWS. If it's Azure, we will specify Azure. So plugins. So this is where you specify the plugin you want to use. In our case is Amazon. And then we say for Amazon, source plugin where you should get the plugin from. It is on the Amazon, is on the HashiCorp Amazon GitHub. Let's show you that. Let me do it first and I'll show you. GitHub. So here we are specifying the plugin that would allow it to work well with Amazon Cloud. HashiCorp /Amazon. And then we will specify the version is should not be greater, should not be less. And this is not the version of the HashiCorp, but the version of the plugin that's being used. Should not be less than 1.2.0. That's the minimum we want to use. So this repo, this is somewhere in the HashiCorp repository. So let's go HashiCorp. So you see it. Let's see if we can quickly find that. Okay, let's go GitHub HashiCorp. And HashiCorp has its own repository, lots of it. You can see a lot of it. And what we are looking for is, let's see, Amazon. Okay, and then this is the Packer plugin. You can see that that's for Amazon. So there were for Azure and the rest of it as well. So that's why where it's gonna download the plugin from, and this is the first thing we need to set up. So we can call that, and then after doing that setup, obviously, which is very important to so we then need to basically now, because we are creating the image, let's say, let's just put some, let's put some comment here. Let's say, let's do something like this to make it just look a little bit smart. And so this is just adding comments, okay? You can just say now source, just put some comments out to how we build the image, the AMI. Okay, these are all comments. It's not really code. It's just to kind of make things a little bit fancy. Okay. Anytime that you put comments, it's then basically ignoring, but it helps you to know what you're doing there. So now we basically will specify the source here. So the source here is that we're going to use Amazon EBS, Elastic Block Store, Amazon EBS. Let's give it a name. So we're specifying, let's call it Nginx. Git. Let's call it that. We can give it any name, but this is important. The source we're going to use Amazon base, so you can't change this, but you can give it any name you want. Okay. And then we'll basically write out what we want to do. So when we are creating our image, okay, we want to specify the region we're going to need. Okay, let's see, region. Also, we want to specify the instance type that is going to use, instance type. And then we also want to specify the SSH user that is going to use to log on. This is the username. And then also we want to specify the source AMI. So source AMI. And then we want to specify when the AMI is created, we want to give it a name, AMI name. And then another thing that's important is we want to specify the virtualization, which would be HVM, so which is hypervisor. So we can say AMI virtualization type. Okay, and then so this one we're gonna fill them up. Okay, let's start with virtualization type. That's easy, you know. We're just gonna usually just use hypervisor visualization. The AMI name we want to give it. So in our case, let's just give it like let's say Nginx Git by Parker, something like that. Let's call it that. And then the source, we're going to look at the source in a bit. And then we are going to, let's give it a name. Let's just use EC2 user. Let's use that, which is what we've always used. And then the type, let's use D3 micro. That's what we've always used. Okay, the region, let's use the one we always used. Let's use EU West 1. Okay, it's kind of coming all together now. Basically, all right, so agent is to type username, source AMI, we're gonna look it up now, virtualization, and the rest of it. So this is all good. This is the name we chose. And then let's look at the AMI image. Because we are trying to mimic what we did manually, if you recall, the journey will start from this AMI, which will be this one. Let's copy this image ID, which is the Linux, the AWS one. Let's copy that. And let's use that here. Okay. Right. That's the one I would hope. Okay, so now we've got this. We're gonna arrange all this one later to make it look a little bit nicer, but we'll come to that later. So let's just do that, okay? That's all good. So now, when we spin this up, what else do we want to do on it? So we want to kind of lay some things on it in terms of what it needs to do, essentially in creating the system. Okay, so we are going to define our build. So let's just copy this. I just want to kind of walk us through the code so that we understand it, and then we know what it's doing, and then hopefully when we're generating our own, we're gonna do it a little bit quicker than this in the next couple of classes. But I wanted to also kind of run through it just to get the basics of it, and then we'll build on this and make it faster later. Okay, so let's call this maybe build phase, something like that. Again, what you do here, it's not really important, it's just comment. So you know what we're doing here. This is we are source, which is this source we are creating. And then we then add some provisioning to do something like that. Okay, we'll just do that. Just make it nice. Okay, and then essentially what we then need to do is we want to label what we want to do, which is installation of obviously Gates, Nginx. This is where we then define. So this is the image being set up potentially, and then this is us now laying stuff on it. So we want to build stuff on it, right? So we create our build phase. So we give our build a name as well, just for good measure. So we give it a name, call it Nginx Git AMI build. Got Git AMI build. I only click better than this. Okay. Let's do that. And that's what we're gonna do. And then when we are doing this build, we want it to target this guy. Okay. So that's the one we're gonna target. So we're gonna target this source, this name. Okay. So we wanted to target our source, which is basically Amazon EBS Nginx, which is our source here. So that's what we want to target. So this build is going to be targeting that source. So we have to specify the sources. In this case, it's just one source for this build. So we say sources. And in that case, it's going to be a list of sources, but in that case, it's just going to be one source. So we say this guy. That's the one we're targeting. But the way you're going to specify it is going to be interesting. So that's the one we are targeting to do the installation. So the source here is what we want to target and install Nginx on. So when this is created, an image is created, and we want to kind of write some code to target it. So this is the name of this build. It's not terribly important, but what you should target is important. In that case, we want to target this image when it's built. So the way you say it is sources. In that case, it's just this one. But it has to be, the name should be properly specified. It will be that dot that dot that. And that's how you specify it. So to be able to see it. So in that case, sources would be this guy. So this dot that dot that. And that's how you specify the source. We are saying, okay, it should target this, and that's the full name of what it should target, which is when that system is provisioned. So that's the sources. In this case, just one source. But what should it do? And that's what you then say, I want to do the provisional. Okay, provisional. Provisionals. So let's say provisional. In that case, we just want to run a bash shell command, just basically run Linux shell. And then we then specify what we need to do. So we're going to put a couple of code in it, and then we'll say, because we're just going to be running some Linux command, we'll say inline, and then we'll specify what we want to run. Okay, so it's all the sudos. So sudo, let's do the update yarn. Essentially what we did, update -y. Okay, that's the first thing we do. And then we'll do sudo yarn recall install nginx -y. Okay, and then what else did we do? We then say sudo system control systemctl enable nginx, you recall. And then we also then started the nginx sudo system ctl start nginx, I think, yes. And then we also did some magic. I think we did sudo, we updated this little file. So we updated this little file, which is the USR share nginx. You recall, we updated the file just to kind of show our little thing, nginx HTML, and then index the HTML file. We did update that, and the way you're gonna do that, because you can't use Vim here, so we have to be a little bit creative. So what we're gonna do is we are going to do, so in that file, probably we want to put something like this. Remember what I did earlier the other time? So I did something like H1, which is hypertext stuff, and I say something like, I say hello from template, right? So let's say hello from template. Let's say by Packer. Let's say build by Packer, something like that. So this is what we want to put in there. So we basically would close it up /H1. So this is just using hypertext. This is terribly not important for now, but let's just do it. Don't worry about this if you don't understand it. So this is what I want to display when a system is created. So I'm going to find a way to push it into this file. So what I would do is I'm going to use echo command to push it. And I'm just going to target this file. I'm going to say sudo. I'm going to say sudo. I'm going to use T. So what T does is it will write this, it will write whatever I send into this file and then also display it on the console. So what I want to do is I'm going to use echo. So what I'm saying is I'm going to push this into this file. That's the summary of it, so that this file will have this content. And that's the summary of what is going on here. So echo that into this file, and that's it. So this will be the sort of the end of the Nginx kind of thing, really. And then we will also do sudo yum install git, and yes. So I think that is all we need to do in the inline. And then if we have anything we want to do post installation, we can actually do the post processor local shell. So basically, let's say there's some other thing we want to do after all this is installed. There's also a post process stage that we can implement. In this case, we're not doing anything, but it's just for good measure. Noise is there. So say if you want to delete some file post process, so use the processor processor, if I can type processor, and then you give it a name, just say so in this case we're just going to do shell local. So shell local, which is basically will run on the machine when the machine is all processed up and ready to go. We're not going to be doing anything. It's just kind of to show us that it's the things we can do here. I just say inline again, and then just for good measure, just put something like it's all done. Echo, echo, AMI build is finished, something like that. So you know when you see this message, you can rest up and know that it's all done. So let's make sure we're not missing anything. I think that should be it. So this closes there. And that closes there. So we've got the code pretty much intact. So let me just run over it and then try it out. So where are we? Unless the file, so this is the file. Let me use Packer. So I'm going to use Packer to process the file. So Packer help. Let's see what we can do with Packer. So you can build, you can do console, you can validate and know the rest of it. So let me first and foremost just format just to make sure that the structure looks fine. So let's do car format. Okay, blah, blah, blah. Write all the option with templates currently, back of file, format, canonical structure, format options, check. It inputs recursive, also preserve file, right? Okay, let's not worry about this one for now. So we're gonna come to this and look at all the options later. So what I want to do now is basically process the code we've written. Of course, when we get this code all working, we want it to target our AWS platform here. and then do all those little beautiful things and have eventually we're going to have a new AMI in our custody here in AWS, but it's just an onboard code for now. Okay, but that code needs to find its way to using AWS. So what we need to do is we need to do a couple of exports of the credentials Packer is going to need. Let me just clear the screen. Packer is going to need to connect to AWS. First and foremost, let me see Packer validate. Bear with me. Packer validate. Okay, right. It's just basically checking out the option. Okay, cool. So now let us screen. Okay, cool. So now we've got the code. Now we want to basically start building it out. The first thing we have to first and foremost worry about is how do we get Packer to talk to our AWS platform? Okay, how do we get it to basically communicate with our AWS platform? To do that, we have to export our credentials to AWS and export our key that we generated in the in AWS Amazon Identity and Access Management a couple of weeks back. I'm going to show us now to remember it. If you don't have the key, you will have to probably generate a key again. So what do I mean? So for Packer to work, we need to export some certain key that is going to need to authenticate to the AWS platform. So what I mean by that is a while ago I mentioned, okay, Cynthia, yes, quickly, so we don't lose our thoughts.
Sorry, I have my question on the chat.
Okay, let's see. Okay. All right. Yeah, please put it there. I don't think you've done it yet. So yeah, do it and we will look at it. So we need to set up
Is there already? Sorry.
Is it there already? So you want to take it because I can't see it, to be honest.
Okay, so my question is, sorry, just to take you back a bit. When we were writing the line codes you want inside the machine, that is the Packer command you were given it, the sudo. You have the echo there. So the echo, you wanted to move the echo hello from TechBlitz. So my question was just, that folder, are you creating this folder? Is it local on the
This
machine?
is not, okay, so this is not a folder. This is a file that we are creating on our local machine. We are writing a code. It's just like writing Terraform, yeah.
So that's what I'm saying. So this hello from TechBlitz, that's line
This
42.
one, yeah.
Yes. So so this thing you said we're going to copy it into this index file.
Yes.
So that's what I'm asking. So the index needs to be somewhere. So you need to have like a folder or wherever locally in your machine, right? I thought.
Right. I get it.
Do we need a command to do that first before?
No, that's a great question. So Cynthia, what you have to realize is there's some installation going on here. So you have to ask a great question. When Nginx is installed, this file is created for you after you've done your installation. This is the one that would create a default file for you, which is the Nginx install. But we are overwriting this file so that we're going to have something like this. Recall when we, let me show you. Remember when we provision these systems, where are they? Instances. Comes, these instances, what we did for this instance is we copy that and you bring that here and then you do HTTP. You see, hello from TechBlitz. You know how we generated this? We just edited the file on the system and then we say hello from TechBlitz. That's how we created the file, but we didn't create the file. We just updated the file. Nginx will create his own by default. So what we are saying this code is we are overwriting that default with hello from Packer. So we don't have to create the file. Because when you do the installation of Nginx on that VM, this file will get created for you. But we are just saying we are all going to override what is in the content of the file. Does that make sense?
Yeah, thank you.
All right. So now So what we're gonna have to do next is we are going to get the keys. If you don't know how to get the keys, because you're gonna need the key for authentication. So we're gonna do IAM, Amazon Identity and Access Management. So we go here, and then I already have the keys. I'm just trying to remind you. So you go to your users. So this was a key we created. If you don't remember what your key is, it should be in your download. But if you don't remember, you can always generate a new key. So let's click on this guy. And this is what we are talking about is the security credentials. And then it's this access and secret key. If you don't remember it, you can basically deactivate and create a new one. And then you can then get the key information. So you can create a new one. I think you can create up to 2, but you can deactivate this one or delete it if you don't remember it, because you need more than this. The key has 3 things, I think 2 things. 3 things actually: ID, access key, and secret key. So but you have to download the one you created. So if you don't remember it, you may have to generate a new one. Let's go back to EC2. Okay, so we click on that. Then we're gonna wait up for, hopefully when the image is created, we're gonna see it. Actually, let's go to instances first. So we've got this too. So when Packer begins to run and we get it right, we're gonna see a new instance created here from which is gonna derive the image is gonna build. So let's kind of continue on that line. So in my case, I need to export the credentials, access key, secret key, etc. So I would say something like export. So I'm going to export my AWS access key ID. So I have them. Let me just get them, which is my own. Paste. So that is my access key. Bear with me. I'm going to get my secret key next. Let me just make sure I'm able to copy it. Got it. So export that. Then I'm gonna get my secret keys. Paste. And I'm gonna specify the default region I want to play with. So let me use West 1. Okay, so access key, secret key, region, and then I'm gonna export those 3. Okay, and when that is done, I'm pretty much close to where I want to be. So with that now, I've got the credentials for Packer to use. And all I need to do now is basically, I will have to then basically test out the code to make sure that, to check out if my Packer is good to go. Right. So, so the first thing I need to do is I need to initialize. So after this is done, export all this. So I will do Packer init. When I do Packer init, what happens is Packer will basically download the plugin that it needs to do the work. And then it will do some initialization, create some folders. If you see what is here now, we don't really have much. This is what is here now. Somebody raising his hand again. Okay. Why do you export the key? Yeah, I don't like configuring them. That's a great question, because when we move to auto provisioning using Jenkins and all the rest of them, the AWS console configure would not work. So I'm just sort of preparing us ahead on how this is going to be managed when we move to provisioning using Jenkins, maybe Azure DevOps and all the rest of it. They use Explorer and AWS. If I use AWS configure now, you will not be able to use that option. So it's just familiarizing us. So if you know configure, use configure. But I don't want to lead us along that line. So the export is the best option. And that will become apparent when we move to using Jenkins for pipeline. Cool. All right. So let me clear the screen. You can see currently now we only have the Git and AWS thing there. So we're gonna do Packer init. So say Packer initialization to download the plugins that we need. Initialize here. So it basically is a begin to initialize and it's saying something is not right. Valid expression in line 31. What's it saying? The start of the expression with final expression token. Let's see what we've got in line 31. What does it not like that? Build name. What is wrong with build name? Right. That looks okay-ish to me.
It's supposed to be double quotes. So double quotes.
It wants to be what?
Double quotes. Double quotation.
Oh, okay. Let's see that. Okay. Yes, you're probably right. Let's do a double quotes, and that should hopefully get us off the line. Yes, I think you made it right there. I'm just trying to see. Yep, let's do that. Okay, let's test that. Okay, that looks good. And then now let's do Packer build. Packer build, which is basically to build it out. So Packer build from here, and then that should get things moving. So it's basically going to start because spinning up a VM for us. So if we go here, let's see, refresh. You can see now this is Packer doing his work. You would generate this VM and then do the install, and then we delete the VM. So when all is said and done, what we're gonna end up with is you're gonna come to AMI here. We're gonna see a new one when it's all done. So let's wait up. So it's doing all the installations and stuff. Okay. Right, that takes a while. So one thing also with my account, sort of complete, blah, 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 install, it's generating, preparing the page, stopping the instance. Now the instance is being stopped because it's going to generate a VM of it. So instances, you can see this is still running and it's going to be stopping it now. So it's done, it's deleted it. So it will be generating the image. When this is all done, we will see it here. So let's go back. Waiting for instance to stop. It's trying to stop it. Hopefully, we'll be able to stop it real quick. And then we generate the image. So the idea is that this we can then package up and put it in GitHub. So we can basically manage the state of our machine beautifully. Let's see. Okay, AMI is so it's giving us an AMI ID. You can see that, right? And then let's see, where is it? So refresh this page. Let's see, and then let's go back. Okay, we've got that now. So Nginx Git by Packer, can we see that? And still pending to be created, but it's all done. So if we just quickly, so the image is created quickly. If we spin up a new instance, okay, that image is being created. I don't want to rush it, but let's assume that it's done. So launch instance, and then we'll say node from Packer. Okay, and then we'll specify my AMI. Hopefully that image is ready to be picked. Let's see, is it ready? Is it not? Okay, it's there. So this is the Packer one. Okay, and let's choose that. And then instance type everything as normal, master class, and then allow HTTP from the machine. One thing we didn't do is, okay, anyway, was select the master class. So select that, and then let's launch it. Okay. So this is gonna be launched, and instances. So if we've done this well, obviously sometimes you don't do it and you create the image and you create the image and you create the image, recreate the image until you get what you need. Sometimes you don't do it in one go because you might not get things right. So that is very normal. But in that case, let's just check. And then let's go here. Let me just override this one. This is hello from TechBase, right? So let's put this one here. Let's see if it's all running as it should. Okay, I don't have it copied properly. Go back. Okay, should be neater now. Bear with me. Okay, I just want to look at instance state. I want to filter by instance state is equal to running. Can you always filter by that? I can just what have I done wrong? I can't about instance state. Anyway, instance state is running. Okay. All right, cool. So this is it. And then this is the one we need. And I was trying to get the public IP. I'm just trying to put it here. It should not be any of templates. Let's now see this. HTTP. Use that. Okay, now it works. You can see hello from template built by Packer. So this is working as expected. And yeah, and that's good. So all we need to do at this point, obviously I just use that to test. I'm gonna delete it. All we do at this point is if you go back to our little diagram, so we've achieved using Packer to spin up the AMI, and then basically we generate a new AMI. I just manually created a VM of the AMI. It is this leg that we're going to look at tomorrow. Instead of using manual means to generate this node now, we're going to use Terraform as a way to generate nodes. So we'll no longer be using manual means of clicking to create nodes. So we have Packer as the leveraging code to generate the AMI, and then we're going to use Terraform as a way to create VM of an AMI. So Packer plus Terraform will then help us achieve node creation using code. And that is creating your infrastructure using code. So infrastructure as code, we are mixing Terraform and Packer to give us that sort of way to automate VM creation. So all I need to do here, which is very important, is I'll look at what has been created here. So if you look at here, so LS1 has ALTR, so show everything that's happened so far. So we've got our little stuff here. So all I need to do here is I'll go here and I'll commit the change. I will say I'll say Packer code build. I want to see the file is going to commit, so I'm just going to commit it. Okay, right. So, and then I will then push and then it should go into the repo. So if we go back to our little code base here, we can find it. So GitHub template, and then we go to the new template repo repositories, class, that one. Okay, now that's the file. So we've got the file there. So which is all good. And this is where we're gonna stop. So for tomorrow, we will create Terraform to feed off the AMI. The AMI is created, and then we're gonna see how we can use Terraform for the AMI creation. So any questions or comment before we end for this evening? How often would you work in console as a DevOps person? Honestly, that's so what Case asking is, how often would you be doing click work? I know we have some DevOps guy here on the platform. So the short answer to your question is that it varies on the maturity of the team we are working with. So some team are very DevOps aware. So imagine you're working for a company like NVIDIA. You have to be a top notch, and there will be standards there. So you probably will not be using console very much. Everything will be code based. But if imagine you're working maybe for Shegun, Little England company. So maybe you are the godfather of everything in the DevOps unit. So you do what you want basically. So I think it depends on the maturity of the team where you find yourself. That's the short answer. So Cynthia probably will tell you, because she's a DevOps guru, so how things works in our office. Are you always clicking, Cynthia, or are you writing code?
No, everything is done via the code.
There you go. So it depends on where you find yourself. So that's the short answer. Okay. All right. Thank you, ladies and I think I can say ladies. So ladies and gentlemen, thank you. We'll speak again tomorrow. Have a good one.